So first, let me introduce you, Irina Kostina. She's a technical advisor, cloud solution architect at Microsoft, and today she will talk about Security Development Lifecycle. Stage is yours, Irina.
Thank you. While I'm sharing my screen, it takes a bit of time these days. Really nice to meet everyone. I hope you can see my screen by now.
Yes, we can.
It's good. Well, so I will talk about Security Development Lifecycle, DevSecOps, and a little bit about tools which can be used, and then we will proceed with Willard's part about vulnerabilities with linters. Let me jump straight into the into my part, and I would like to share some numbers with you. It's actually from our competitor IBM from the last year. The reason I want to talk about these numbers is to basically outline how important it is to care about security. But the cost of data breach last year for the large organizations was $5 million US dollars. And even though for the smaller organizations it was twice less than that, it is still a very it is still a lot of money, because if we look at the amount of money per employee, it is actually way higher. So we can make an assumption that it actually hurting small organizations even more because they have less revenue, they have less resources. So, and the cost of the data breach, which were calculated in that report, they included pretty much everything, starting from the detection and escalation costs, then some notification costs, like all the emails, phone calls you have to do to communicate during the incident, and also, of course, direct and indirect losses for the business when you have when your systems are down, but also all the lost reputation afterwards and an ability to get new customers and all the business disruption afterwards. And this is just an average numbers, but I also have an example of company called Equifax, and that incident happened not such long time ago in 2017. The company is doing credit scoring, and their overall losses were like tremendous. They spent more than $1 billion or just fixing security afterwards the incident. And the reason I'm actually sharing these numbers, I understand that we all hear technical people, but I just hope that if you don't have security practices in the organization, at least it can help have conversation with the management, because, well, this is the only thing they will care in the beginning is how much will it cost and what are the risks and things like that. And a lot of companies we see right now, they do have attitude that nothing is going to happen to them. And okay, until nothing has happened, why do I need to spend money on security? Well, the idea is that essentially it's actually cheaper to prevent things instead of fixing them afterwards in a very short period of time when the incident happened. But so, and in comparison to this incident, I also have another one. It's about Starbucks. They also had a similar vulnerability. Actually, I didn't mention what happened to Equifax. They basically just didn't patch Apache struts, and someone used that vulnerability in outdated open source software. We can of course say that it was Equifax's responsibility to patch it, but it could easily be that it's 0-day in the Apache, and then they will get all the attention in that case and all the blame. So that's why companies and software developers, we have to be really careful with what we're doing, because it can lead to very dangerous things. But anyway, so the Starbucks just had losses of $4,000 because they signed up for the bug bounty program. And of course, we can say that their overall spend on security is probably higher because they paid for other bounties. They probably also have some processes in place. But anyway, at the end result, they did not spend probably $1 billion on cybersecurity. And of course, it's always a balance of how much we want to spend on the security. And I'm not talking here about buying Windows Defender. It's about all the resources invested. Also, how much tech team want to dedicate to this. And I think we can do a lot because it's a lot of free tools, and it's really comes down to how do we organize our processes in order to incorporate these tools and all the practices. So this is why I would like to share about Microsoft Security Development Lifecycle, which is these days called Security Development Lifecycle. It's used widely in the industry, but I think it was just born inside of Microsoft. And it's a bit funny because usually you don't think about Microsoft as a security company, but with the amount of funds which is spent on cybersecurity, and also the activities which Microsoft is doing, such as taking down the botnets or cyber criminals. It also involves a lot of people in our organization who work in a legal department to do this. So, but anyway, so the security development lifecycle is basically a methodology. It's number of practices which were born inside the organization, and it's more about how do you function as the team, what kind of standards you have, what kind of third-party components are allowed to be used. And I would like to focus on these three today because I think they're the most relevant for developers and architects. But of course, it's important to understand all of them, and because when we talk about security, it's important, for example, to start from number one, which is provide training. Security is everyone's job in the organization. Everyone needs to understand the attacker's perspective and their goals. So we need to raise the collective knowledge bar in the company. I just want to fix so that I can see you and also can see the chat if any questions, but nothing so far. So number of practices also talks about that we need to have security requirements and design requirements, that security and privacy has to be fundamental aspect of development methodology. And there are certain factors that can influence these requirements, such as maybe something from industry, some regulations, but it can also be that we have some coding practices or some review practices, or perhaps something coming from the previous incident. Then this practice about performing threat modeling, I will explain a little bit more about it later. But it's basically about that we need to think about and model the threats which can occur as early as possible in the process. And I also will showcase a tool which will help with that. So also, of course, it's important to use approved tools, and it's important to take action on the third-party components. That is essentially what Equifax failed to do. they did not manage the third-party components such as Apache in their system. They didn't patch it in time, and you basically need to have some processes or use some tools. There is, for example, Dependabot in GitHub, which is a free tool. There is a dependency check, and you can incorporate this in your continuous integration process. You can execute this automatically, these checks when the build is happening, for example. And the same goes for the static tools and well, not so much for dynamic analysis, but there is a number of tools you can incorporate in the development process in order to automate the development, in order to incorporate security in the development process. And there is also here that you need to perform penetration testing regularly. For those who haven't heard about it, it's basically an analysis of software performing by someone who is executing actions which hacker will execute on the system. So it's basically the goal is to uncover potential vulnerabilities. And there is number of resources such as HackerOne, which I mentioned before, or BugCrowd, which has a lot of professionals who do this for a living, and you can just sign up for a bug bounty program there. And the last one is about establishing an incident response process. In a big companies, usually there is a dedicated team for that. But you can also dedicate is it as a role in someone in your team. But it is also about having a process in place, having a plan what you're going to do when incident happens, and also testing it before it happens in order to be able to, in order to be prepared to the situation when it happens, not to do something stupid and panic. But if I deep dive now into threat modeling, there is basically 5 steps involved in this. It's about defining security requirements, then creating the architecture diagram for it, then identifying threats, mitigating, and then validating. And there is a free tool for that, which I will just show in a moment. And also there is a resource which maybe you would like to check out. It is similar to Agile Manifesto, just describing about what is threat modeling, why is it important. But let me just start from the beginning. We have a free tool called Threat Model, and you can create diagrams there. But I already have one. I will just show an example of the already made diagram there. I don't know why my computer is suddenly slow when I'm sharing the screen. But are there any questions by now?
Irina, I can maybe fill in by posting the links to some of the communities you mentioned. So the first one I am posting is BugCrowd. Is that correct? So I just posted. Yes. And the second one was HackerOne.
Yes.
Right. So that's also there. And the threat modeling, the manifesto, you already had the link on the slide deck, so that's fine.
Yes. Yeah. So now loaded. So well, there is number of already made components, not only about Azure, but any components you can basically use in the software development. But if we look at the example of what I have, it's a system consisting of API, web application, database, I don't know, application insights. There is also Active Directory somewhere there. So once you've done this architecture diagram, you can perform a analysis on it. And this is just generating a list of what potentially could go wrong in this system. The category here, it's divided into 6. Basically, the idea is that any software falls down into 6 potential vulnerabilities. So we can, for example, have a look at this. It found potential SQL injection in our architecture, and it's nice that it actually highlights where it is, because if it's a big system like a SimCorp Dimension, let's say, it will be really hard to find where exactly it happens. So it also has, well, okay, category and has description. Perhaps priority, well, how actually dangerous it is. You can also assign a status, where is it in your discussion process or mitigation process with this issue. And this tool is basically used in order to have conversation with your team, not exactly telling you that you have an SQL injection there. It's potential, and you need just to have a conversation within the team, what we're going to do about it, how we're going to prevent it, things like that. And as I mentioned before, the threat modeling, the idea is to execute it as early as possible in the process. This is what's called that right now security is shifting left, and this is what it's all about. Because in a traditional development process, security issues, they hopefully arrive in operation stage, but in many cases they already happen when the software is already in production. So in order to achieve this, we need to identify these defects as early as possible. And the general DevOps approach introduced the processes like continuous integration and continuous delivery, which were ensuring the active testing and verification of the code. So DevSecOps is actually building on top of that practice. The idea is that security audit and penetration testing is injected at certain points in the development process. So, and often when we talk about DevSecOps, we're talking about assume breach methodology, which basically means that it's not a matter of will you be hacked or not. It's just a question of when it will happen. So we need to assume the worst and prevent all the possible issues which can arise. And for that, there are different things we can use. Well, such as threat modeling, but also the static analysis tools or dynamic analysis tools, vulnerability scanning, pen testing, and all the things which already been mentioned. But before I showcase a couple of tools, I still have 1 minute left. It's important to mention that there is a classification of all of the vulnerabilities, and the most popular framework is OWASP. You can study on the website this classification. It explains also what are the the risk and how to mitigate these vulnerabilities, and the examples of how you can actually use them as an attacker. But the reason I'm mentioning this, because all the tools, they actually use this classification. They also they categorize vulnerabilities based on this methodology. And when we talk about static analysis tools, it is basically tools which provide real-time feedback they can help fix issues in the code before they are going in the next phase in the process, and they highlight the exact source line in the code, sometimes not even the line, but the exact position in the code. So it has number of strengths, such as it scales well, you can execute them on every build. But also on the bad side, it actually has a lot of false positives. Sometimes it highlights things which, again, like are potential, not exactly they are the vulnerability which can be used. I would quickly, I'm really sorry that I'm running over time, but I hope it's okay.
It is perfectly fine.
Okay.
We can use the time from Q&A. No need to rush, Irina. You're going good.
Thank you. So GitHub introduced the code scanning capability. Right now it's in preview, but you can sign up for it and it's free. I have some repository with potentially vulnerable code. So it's called code scanning alerts. By default, you have to enable it. There is another button here, but let's just have a look of what did it find. So, for example, it found some potential cross-site scripting. Well, I guess it's complaining that the query param is not sanitized, but here in the description, we can actually see it explains what exactly is wrong with this code, some recommendation, but also it provides how, like example, how it could be misused so that you can actually try it yourself. Another thing in GitHub, it's also built in. I have it in another repository. As I already mentioned, there is a possibility to scan the code on the dependencies. So if you're using some third-party components which are vulnerable, it's possible to identify those automatically. And usually when some software has a vulnerability, it is assigned CVE number. It's like official number in some database, and it has all the information how to misuse it, but also how to mitigate it. So GitHub also has built-in capability to identify those vulnerabilities. It's called Dependabot. And well, it also assigns some some status to it, how severe is the vulnerability. So, for example, it found some actually multiple CVEs for the version of this dependency which we have here, and also provide some recommendations to it. So I think I will pause here. But I really, if you're using GitHub, I really encourage you to enable the code scanning because it's for free, and also the Dependabot. It doesn't cost you anything, but I think it provides a lot of value. So I don't know if there are any questions at this point.
Irina, there are questions, but if you like to complete your presentation, we can also take the questions afterwards.
Maybe if I can just mention what is dynamic application testing, so that we have a complete picture. It's basically process of testing the software in a running state. It works by implementing some automated scans that simulate malicious external attacks. So one example is, for example, injecting malicious data in order to uncover SQL injection. For example, this kind of tools, they test all the HTTP and HTML access points. and it can emulate some random action using vulnerabilities. But so that because dynamic security testing tools, they do not have access to the source code, they have to attack the application externally. So this is the difference between the static analysis and dynamic. And that brings the limitation on what kind of vulnerabilities you can find with it. And I just put here as like to outline what can be found with what, and there is also an overlap. So the point here is that ideally you should use both in the process. You can't go only with one sort of tools or another. So if you want to cover everything, you need to use both of them. I think I will stop there for now.
Thank you so much, Irina. I know how it feels and how it's difficult to talk to the air, not seeing any of the participants. So maybe you can stop sharing the screen. Yep. For people like me who have only one screen, we can see the participants. Now, thank you so much for the good insights and very practical and applicable tools and approaches. We have questions. My suggestion would be, folks, you can read out your questions. So, Rosario, would you like to shoot your question yourself?
Yeah, sure. So, thanks, Irina, for the nice talk. My question is about the example that you show of misusing so that you shown an example of a scanning code, and then the tool also said an example of misusing that piece of code. So I was wondering that example was built on the actual code, or is a general example? So for instance, is a cross-site script attack. So it's a general example of cross-site script attack that is independent from the actual code that it was scanned by the tool.
No, I think no. I actually think it's just an example of how you could use, but for example, I tried to use those examples before on other, this is not my code, but like, I tried to take that example and use it. So it's very close to reality. So, but yes, it's not built exactly on, and it is an example of how would you use it as an attacker.
Okay.
It's the code which you will inject, for example, as a cross-site scripting payload.
Matthias, does this also touch your question, or is it very different?
Yeah, I'm also unsure. my question was just you showed this Lodash. Yeah, I might just ask it anyways. So my question was regarding this third-party package you showed and what security issues it has, and I was unsure if it also regarding the code from the repository, or was it like a general outline of security breaches that the version of that specific package can result in.
Yes, so that tool is scanning all the dependencies you have in your project.
Yeah. So
it only shows that in IODash there are these vulnerabilities, and there is a database of all known vulnerabilities in IODash for each of the version of that program. And depending on which one was used in my project, it found which CVEs are assigned to that version. So I don't know if it explains.
Yeah. Because so it's basically you still, as a programmer, you have to do your own scanning, so to say, of your own code, and if that problem applies to a code.
Exactly.
Is that correct? Okay.
Yeah,
yes.
that's a good point. That you need to actually. So yes, IODash might have vulnerability, but does it actually affects your software because maybe you're not using that functionality? Yes, good point.
Yep.
And Willard, back to you. Sorry for skipping your question because these two were kind of related. So over to you for your question.
All right. So thank you for a very good talk. I just wanted to ask about SDL. how much it burdens an organization or a dev team when they adopt it. Because it seems to be very useful to help identify security requirements, but it looks like a lot of elements that if you take them all at once, it might be a bit of a bit overwhelming. So I was wondering if a team can adopt the elements individually, like cherry pick the ones they find they need, or do they have to like take the whole thing for SDL to work?
Yeah, of course. Well, it's probably going to be really hard to adopt it all at once. I mean, it's the same if you want to adopt DevOps in the organization. It takes a while. So
Right.
I guess it's also depending on the appetite, like how much you want to spend on security, because it's always, you know, a burden to organization. So I guess it's a question where to start. Actually, we have on Microsoft page, we have we have a page where it will help to basically assess where you are right now on this topic, and then build a plan. What can you do gradually? Maybe I should just share the link, but it's official Microsoft SDL page.
Okay. Yeah, good.
Enter, can't hear
Yeah,
you.
Enter, you're muted.
Yeah.
Thank you so much, folks. Really appreciate it. So I was just saying that from the audience, are there any other questions? You can just unmute and talk. I was saying, and I didn't unmute myself. And thank you for the link, Irina. Yeah.
Question from my side. The first tool that you've shown, based on Azure, do you get this part of an Azure subscription, or?
It's not even on Azure. It's like a desktop tool. It's free. I can post a link on it if that will help.
Sure.
But yeah, it's not tied to any subscription. It's just a free tool.
Okay, so we got one more question. If there isn't any other questions, I suggest let's thank Irina once more, and let's continue with our second talk. Yes.
Thank you.
Thank you. And the second talk, our speaker is Willard. I'm always mispronouncing, but Rafnsson. Is that correct, Willard?
In my language, you would say Rafnsson, but the FN sort of sounds like a B, but any approximation thereof is fine. I'm used to it.
Thank you for the original pronunciation. So he's an assistant professor at the IT University of Copenhagen. As I said, he has some co-authors and students with him today. So one of them is Rosario, who already asked a question. And the topic is fixing vulnerabilities automatically with linters. So there is a paper behind it. And the stage is yours, Willard.
Great. Do you see my screen?
Yes, we can.
Okay, perfect. Yes, so hello everyone, my name is Willard. I'm an assistant professor at the IT University in Copenhagen. In the crowd today is Rosario, who is also an assistant professor at the IT University, with whom I co-authored this work. This is work by two of our bachelor students, Mark and Matthias, whom couldn't join us today, but I'm sure they're just as interested in any kind of feedback to this as we are. So I'm going to start with a bit of a motivation, which is that it is a sad fact that developers, they write vulnerable code. We'll get to in a bit what a potential cause for this is, but the fact remains that vulnerable code gets produced. So,
Willard, can I interrupt? Sorry. There is a little picture showing me. Maybe you can minimize that.
Oh, yes. This thing?
Yes, super. Thank you so much.
All right, good. So yes, so this is some graphics from NIST, and it shows how vulnerabilities have evolved over time. You can see on the far left, as far back as 2010, where you had the most common vulnerability which was like input sanitization bugs, like which lead to cross-site scripting attacks. They were most common. And then you see that it looks like they're about to be solved, but they sort of trend up and down again. And now again, they are the most common vulnerability in software. I've marked in bold on the right all the vulnerabilities which do not have anything to do with memory protection, because I figure if you use a programming language with that built in, then those vulnerabilities will be solved. So I'm focusing more on sort of application logic vulnerabilities here. So you see that the most common one is cross-site scripting, and then also input validation to check, for instance, if what you get is actually a string or a positive integer. There's also input disclosure, information disclosure, basically a page that has no authentication check to it that can be navigated to if you provide the right URL to your browser, cross-site scripting attacks, and so on. And if you look at the numbers, you see that the number of vulnerabilities is increasing and not decreasing, so that's a bit alarming. So why is this happening? So you may wonder if, given the amount of security literature and methodologies that have been evolved and developed over the years, why does vulnerable software still get created? You might be inclined to blame the developers, but actually developers, they know, care, and can do security. So they do understand the need for it and the importance for it. So what I'm saying here is the result of various studies, which are linked at the top. So they understand the need and importance for security. So they know that security is about preventing vulnerabilities and unauthorized access and so on. They're also highly motivated to write secure software. It aligns with their personal values. They don't want people's information to leak. They feel responsible for the software they're writing, and they also like the challenge of trying to write something secure. They also tend to pick reasonable tools. They pick well-known and well-established libraries, as opposed to rolling their own crypto, like OpenSSL. They have two-factor authentication. They store passwords securely. They use OAuth and so on. So we're talking in general here. Of course, there exist exceptions, but in general, this applies to developers that were contacted in these studies. So where do the vulnerabilities come from? So the common mistakes were that they would use the tools, the reasonably chosen tools, incorrectly. They would pick, for instance, a fixed initialization vector in a block cipher. They would use insufficient randomness, disable library some protections in the libraries they use. But also it was the case that sometimes the security requirements were unclear. Many times it actually happens that security requirements need to be inferred from functional requirements. They aren't stated explicitly. So a developer who is strapped for time might overlook this. And if he discovers such a requirement after being given a functional requirement from a team lead or a manager, the question then becomes who's responsible for doing this, because they have a fixed amount of time to actually implement the functional requirement. Who's going to implement the security requirement? Finally, using assurance techniques turns out to be too time-consuming often. Developers tend to skimp on full-stack testing and static analysis. And then what are the likely causes for all of that? They are, well, here are some theories. One is that in part it is organizational, because there's a lot of pressure on delivering visible progress fast. So therefore, well, security is often not very visible. So therefore, the developers tend to focus on what is visible, because that's how they're evaluated. Also, who's responsible? It's if the developer doesn't feel responsible for implementing security, that's sort of on the manager. But if the manager implicitly assumes that the developer is responsible, then the task doesn't get done. Procedural, there's often a lack of plan or process or strategy or practices or mandated tools. This is especially the case in small, medium enterprises. Larger enterprises tend to have a security culture, but sometimes these are lacking. Finally, there are frustrations with tools. There are several tools out there that help developers write correct and also secure software, But there are lots of frustrations in the use of these tools when it comes to how they integrate with their IDEs, whether the bugs defined are actionable. Sometimes the feedback they get is misunderstood, and also sometimes they get false alarms from the tools. And then I'm sure you all know the story, the boy who cried wolf. If you have a tool that keeps complaining about some code, and every time you look at the code, there's nothing wrong with it, then the next time when the tool actually complains and there's actually something wrong with it, would you believe it? So the bottom line from this is that the developers are doing the best they can under the circumstances. And there are some circumstances that can be improved, of course, in part the developers, but also the environment they work in. So what has turned out to work is test-driven development, code review, and then using more lightweight tools. So it's that last part that I'd like to focus on today, on assurance techniques that are lightweight, since that seems to have impact in industry. And the tools we're going to be looking at is Linters. So a linter is a static analysis tool, but of a particular kind. It essentially scans, or in other words, lints, code for security issues. Well, sorry, for issues in general. And these issues could be bugs, programming errors, suspicious constructs, stylistic errors, and code smells. So you can see from the kind of things that the linter is checking, it's not the typical kind of things that you see like a static analysis from academia checking. So there, in academia, static analysis tends to focus on like improving properties of programs. Here it's more about sort of guiding the developer. It's less on providing mathematically correct results and more about providing something that is useful and actionable, namely exactly addressing that stuff there at the bottom with the tool frustrations. So linters are much less frustrating to use. You could say that it's static analysis for more tools, if you will. They tend to also have fewer false positives. And the modern linters, they also have the ability for the community to contribute to them. For instance, ESLint has a big repository of plugins that you can download to essentially teach your linter how to find new kinds of bugs. And then developers out there contribute regularly to this library of rules, and you yourself can contribute to this library or keep a library of rules in-house in case you don't want the world to know about it. Linters have been very successful. I'm sure you've used them at some point in your development career. They exist for JavaScript like ESLint, JSint, and Flow. In .NET, this is usually built into standard IDEs. There's Roslyn and OmniSharp. In Python, you have PyLint. Java, you have Findbugs, which is now called Spotbugs, or at least the current living version of this. There's also checkstyle. And then C and C++, so in C there's lint, that's where the name comes from, but there's also C++ lint. Our thesis here, if you will, is that given how difficult it has been for developers to adopt these sort of these academic static analysis tools, given how successful linters have been, perhaps the most impactful way to develop vulnerability checking to programmers is through linters. So this is what we're investigating in this work. Basically, we want something like this, where so this is a part of a screenshot from an IDE, where you have some code snippet there that is fetching something from an API, and then is taking the result of that fetch and writing to the DOM to h.ref, writing basically the result of the fetch. And what we'd like is something like what you see, where ESLint would flag this and say that the ref property might be cross-site scripting vulnerable. And the reason for that is because the result of the fetch, or that might come from a third party, which we do not trust. And if we don't trust it, it might contain code, which we'd have to do something with. So to make sure it doesn't get executed in the client's browser. So as you see here, there's a fix. And the idea that we are advocating is that you as a developer, instead of trying to figure out how to solve this problem, let alone understand what the problem is, you could use the fix and it would do this for you. It would change the code in such a way that you're not just assigning code from an untrusted place directly to a DOM, but you're also making sure to sanitize it first. So that was the goal of our work, to investigate the extent of which linters can help developers write secure code. We are focusing on ESLint because it's the most popular linter for the most popular programming language, and also because it's pluggable. You can download new linting rules from the internet. What we did in this work was that we created new ESLint rules that find and automatically fix vulnerabilities. So these are very simple proof of concept rules. We don't expect them to be earth-shattering in industry, but we did design them to be useful. We targeted the most common kinds of vulnerabilities in software, cross-site scripting and SQL injections and security misconfigurations. So you didn't see the security misconfiguration in the chart that I showed, but that's from the OWASP top 10, which I'm sure you're aware of. We also evaluated, so based on this experience in writing linting rules to find vulnerabilities, we evaluated our experience and also the suitability of ESLints and linters in general as tools for this purpose. So we looked at the strengths and limitations of ESLint, of existing plugins for security, and also on guidelines for developers to create new plugins, whether they align with what you need to do to write a plugin that finds a vulnerability. Finally, we provide, based on our insights, some observations and recommendations that should help push this idea to industry. So first, the new rules. The first rule we wrote is to detect kinds of cross-site scripting vulnerabilities. So what is cross-site scripting? Basically, it is the attacker making one of his scripts execute in the client's browser. One way that this can be done is that the attacker submits consider, for instance, a forum. The attacker might submit a message to this forum, and this message would contain a piece of JavaScript, which then gets saved on the server. After that, any client that browses to the forum would download all the messages in the forum, and because the message contained the script would execute in the client's browser. So this is probably the sort of the simplest version of a cross-site scripting attack. But the concept of cross-site scripting does not require that the script gets stored in a forum like this. It involves just any way in which the attacker gets a script stored somewhere such that the client downloads that script and executes it in his browser. So we are looking at a particular kind of cross-site scripting vulnerability. So sorry about the amount of text here, just to focus on what I'm saying and what's underlined. The kind of cross-site scripting vulnerability that we consider are DOM cross-site scripting vulnerabilities, where you have a piece of JavaScript on the page that calls some API, and the API is untrusted. If the API is untrusted and the JavaScript calls to this API, the result of the call might contain code that would get executed if you don't sanitize it. This is the scenario that I was describing before the contribution slide. So you may have this code with this fetch API, then take the result and assign it to the DOM. So we would like to prevent unsanitized attacker-controlled data. So our approach to this is to look at modifications of ref and source attributes, and the rule that we created will scan the JavaScript that you're looking at. So when you take, if you take ESLint with the rule that we created and scan JavaScript with it, our rule will look for all values of all variables, variable initializations and assignments, looking for patterns like this, where you have data coming from a possibly untrusted source being written to the DOM. If such a pattern is found, the rule will flag that here there's a potential cross-site scripting vulnerability. When it finds such a vulnerability, the rule will inform the developer and propose the automated fix, which is to introduce sanitization. So if you look at the sanitization, you see what we do is, well, we're replacing JavaScript colon with the escaped variant of it. This may not be the ideal way to sanitize. there are libraries for sanitization, and it would have been probably better to use that. But we found that when we look at frameworks for JavaScript development, like React and other frameworks that have some sanitization built in, that they often do not have sanitization that is general enough for the purposes that we were targeting. So this is why we rolled our own, but we'll probably in the future find a better library for this. So this rule has some false positives, because if you're fetching from an API that is trusted or cannot be attacked in this fashion, then it will still be flagged as vulnerable, because it actually flags all API calls like this. The other kind of rule that we created is for SQL injections. So what is an SQL injection? It's a bit vulnerability, except we are here the attacker is injecting code into the server such that the code is part of an SQL query that gets executed on the database behind whatever, say, web application that the attacker is interacting with. The way that could work. So here's a simple example of this: a simple node application where you have a SQL statement being constructed here, select star from users, where a telephone number equals, and then a variable phone. The thing is that if phone is part of user input, and you just concatenate the strings like this, then if the phone also has an SQL query in it, or like a continuation of an SQL query, then that will actually modify this original SQL query. So for instance, if phone is not a phone number, but the string single tick or 1 = 1, then the output would not be that one user's phone number, but all phone numbers, or actually all user records. And you could do other similar things like single tick semicolon drop table users, which would then wipe that table from the database. So our approach to find these kinds of vulnerabilities, the rule that we wrote, is to we instead require the use of prepared statements. This is standard practice today, and yet you see in the chart I showed at the beginning that SQL injections are very common. But yeah, so this is why we created this rule. We don't consider this a solved problem yet. And the way that the rule does this is in a similar way as before. We track variable assignments and we look for patterns like this. If we find a string being concatenated to an SQL query and this string can be user controlled, that's where we flag a problem. So the fix here is that the programmer is informed of this problem, and the way to fix it would be to change this to be a prepared statement. We didn't make this happen automatically. That's sort of part of future work, but the important thing here was to actually find the vulnerability. This actually also has false positives. It actually only looks for bad uses of database connection query. Yeah, so if the function name query is used in other contexts, then this rule will actually flag potential misuse there. Yeah, but on the plus side, this is independent of whatever database driver you're using or what SQL server is being used in the backend. So because it works on the client code, it doesn't care if the server is running MySQL or PostgreSQL or whatever else. Finally, we looked at security misconfiguration, which is something like what you see on the right, like a default username and password. So this is a very generic problem. So this comes from the OWASP website. So this is about attackers exploiting unpatched flaws in software and using things like default accounts and unused pages and unprotected files and so on. Basically, imagine if a company threw up a web server during an afternoon and didn't quite harden it, like close ports and remove pages which potentially contain sensitive information. So an attacker would be able to potentially exploit those things. So this can happen because this is a generic problem. It can happen at any level of the application stack. And the consequences can lead to unauthorized access to data, or even complete system compromise in the case, for instance, where you might be able to execute code on the server or change its configuration. What our rule does, so it specifically targets Node.js backend applications that use the Express web application framework. So this is a very tailored rule towards such applications. And the aim is to look for the use of Express without using the Helmet library. So the Helmet library contains some default security configuration for Express, which are highly recommended. And if you don't use them, you potentially have a vulnerable web application. So so that's all the rule does. It looks for the import of Express. If there is such an import, we look for a subsequent import of Helmet, and if that's missing, we flag that your server might be misconfigured, and that you should import Helmets. The automatic fix is then to simply require Helmets. So, as part of this little exercise where we wrote linting rules to find security vulnerabilities, we evaluated ESLint as a tool during this, and also looked to see the extent of which this had already been done, and whether ESLint is sort of well suited for this or recommended for this by the community, to sort of look at the guidelines for writing rules. So considering the strengths and limitations, so ESLint, its strengths include that it has rules customization. You can toggle rules and write new ones, and you also have a large community repository of rules. So all of this is useful when you're a developer working in a dev team in a company, because sometimes you don't want to check your code for everything all the time. So you'd want to be able to disable some rules. You can also create custom rules and keep them in-house. And finally, you can download rules from the internet or share them. You can also customize the linter itself, not just add rules. So ESLint lets you customize which parser is used to parse the JavaScript. You can use that to, so that's what you use, for instance, to support linting of TypeScript. You can also have a custom preprocessor. This is useful if you have, say, an HTML file or some other kind of document that contains JavaScript and you want to lint that. Finally, ESLint integrates well with IDEs. So all major IDEs, they have, so ESLint has been shipped in such a way that you can import it into the IDE and use it. But it also integrates into a continuous development, continuous integration pipeline, because you also have a command line interface to it. As for limitations, there are no correctness guarantees, but as I said at the beginning, that's not really the focus of linters anyway. Also, this is mitigated somewhat by the rules being community available, so they can be scrutinized, and also by the required unit tests. So all rules should come with a bunch of unit tests. Also, ESLint only scans one file at a time, and this is a little alarming when it comes to large applications. So there are some recent statistics that show that 93% of modern web application code is open source library code. So basically most of the code that you're running is open source code. And as a result, because some of these libraries have vulnerabilities, it is the case that around 70% of web apps have vulnerabilities from a library. And finally, the vast majority of such web apps, of those vulnerabilities are known and can be fixed by just, by, for instance, bumping the version number on a library. But as you know, if you do that, you might have to spend some time reading change logs and figuring out how to make sure that the application works with the new version. So that's why it doesn't just happen immediately. So this problem with one file at a time can be mitigated somewhat with source maps, but still, blame assignment might be a problem there. So so I'll pick up the pace a little bit. So we looked at other rules for security in ESLint, And we're actually surprised to find that there's very few rules for security. And the handful that see notable use, they only identify a few vulnerabilities, and they focus on reducing false negatives as opposed to false positives. And as a result, rules often become too much of a hassle to use, at least we argue. So the most popular rules are ESLint plugin security. So it's popular, but it's also very outdated. It hasn't been updated for 3 years, and it has many false positives. Yeah, I think I'll skip the other ones, but basically the story applies everywhere here. Is that there's overlap between what the rules, what kind of vulnerabilities the rules target. They often have not particularly good documentation. They often have very many false positives, and they're often outdated. So we looked at the ESLint rule guidelines, and here are the guidelines. Basically, rules should be widely applicable in terms of like they should apply to many developers. They should be generic in the sense that they should not be too domain specific. They should be atomic in the sense that they should be unaware of other rules. They should be unique in the sense that there shouldn't be other rules that do the same thing. Library agnostic in the sense that they should not be aware of other libraries than Node.js. And there should be no conflicts, meaning that, yeah, they shouldn't conflict with other rules. As you can see that we already broke some of these rules when we were creating our rules, for instance, the library agnostic part. And that is basically because, well, if you look at many of these guidelines, they actually contradict what something that looks for vulnerabilities needs to work effectively. Because vulnerabilities arise under highly specific circumstances, so widely applicable and generic. So linting rules for vulnerabilities, they counter that. Also, library agnostic, as we saw already, if we're looking for vulnerabilities in libraries, then making a linting rule for vulnerability cannot really satisfy that. And finally, when it came to ESLint configuration, there's a study from a couple of years ago that says that close to 40% of JavaScript developers in the study in maintaining configurations was a challenging part of using a linter. And one idea that we got while working on this was to delegate configuration maintenance to community experts, such that developers would need to figure out which linting rules for security to use. And at the very last, we have some observations and recommendations. So linters can and should be used to detect and eliminate vulnerabilities in software. The potential impact of creating and sharing linting rules is high. And what we found was that the effort needed to create and share linting rules was actually low. We had 2 bachelor students working on this during one semester, and this turned out to be quite a breeze. Yeah, and finally, linting vulnerabilities is an area that is underexplored, but seems to have high impact, at least high impact potential. Our recommendations for linters, however, for this purpose is that they need to be configurable, like ESLint, for instance. Linters shouldn't come with fixed or centrally maintained rules because the security landscape changes so much. No central entity can keep up. This has to be crowdsourced. Yeah, linters need to be able to scan code richly, for instance, not just one file at a time, but a whole code base, including libraries. Linters, they need to have proper descriptions. This is one frustration developers face when using libraries of any kind, that API documentation is often subpar. The whole point of linters is that they're well documented. That makes them successful. Yeah, and linter rules, they have to maximize case coverage and reduce false positives to avoid developer frustrations. And that's it. On the top right, you'll see a URL to the rules that we developed. You're welcome to use them and play with them and provide any feedback. And also, we encourage you to start writing your own linting rules for security and use them in-house or share them. As part of future work, we want to make new rules and also do an empirical evaluation besides this sort of reflecting on our experience. And we also want to do a study on developers to figure out how much of an impact it has in our organization if developers start doing this. So we are researchers at the IT University in Copenhagen, And our goal is to help developers write secure software. If you want to work with us on this or with our students or have questions or comments, then by all means contact us. Thank you.
Thank you so much, Willard. Such a useful talk, very close to the real applications. So I can see that there is at least one question, and that is from the very early slides of yours. Over to you, Matthias. Would you like to ask your own question?
Yes, thanks for your talk. It was actually very interesting. Might be also useful for my coding on a daily basis at some point. Yeah, I know it's maybe not your scope of your research, or at least this particular work you've been doing, but you also mentioned test-driven development could help. I was just curious on if you know any methods or techniques that can help. I know I have also tried myself fuzzy testing, and I don't know if you could, if you know anything about it, or you could elaborate on it.
I see.
That's more than that. Well,
So,
like how you can use unit testing perhaps or something.
So if you let's see. So fuzzing is actually a really effective way to find vulnerabilities. So so if you use something like AFL, American Fuzzy Lob, or if you use yeah, so that's the main tool that I know about. So if you provide it with the right input and then hit go, it's actually capable of finding very unexpected vulnerabilities. So yeah, so you can definitely use fuzzing to find vulnerabilities. As for what helps you with implementing or realizing security goals, I highly recommend what Irina was telling us about earlier, because a lot of security problems happen because they sort of go under the radar. Using SDL would help uncover security requirements such that they can actually be given to a developer to implement. Because if a developer discovers a requirement without having been told about it first, then he needs to make the difficult choice of spending less time on the functional requirement and diverting attention to the security requirements. There's also many static analysis tools. So there's ESLint. There's also Spotbox can find some vulnerabilities. Let's see, other kinds of tools. I'll think a bit more about it and write it in the chat if other things come to mind. But
thanks very much.
Yeah.
Matthias, I guess you were also asking how can TDD actually?
All right.
Yeah.
So test-driven development is the reason that helps is because what everybody would like to have, but nobody has time to do, is to obtain some kind of proof that the software satisfies a high-level goal. So you could do that with like an academic static analysis tool. You could specify the high-level goal as a formula, put it into the tool, hit analyze, and then the static analysis would tell you if the program satisfies the goal that's specified. But test-driven development is sort of midway in that sense. The idea of test-driven development is that you state up front before you start coding, in terms of tests, what kind of properties your code should satisfy. Then you try to implement code that satisfies the tests. So if you think this relates to declarative programming, that you think about what your code should do before you code it, and then usually that uncovers vulnerabilities at worst, but also misconceptions at best. So that's how test-driven development basically helps. It makes sure that you think about the properties your code should satisfy before you actually write it.
Yeah, so you essentially end up writing unit tests.
Yeah, essentially.
But yeah, towards security.
Mm-hmm.
Yeah.
Thank you. Are there more questions from the audience? I know we are 15 minutes over time, so I will not insist very much, but still don't be shy, participants. I can ask a warm-up question. It is actually, I'm asking your gut feeling, Willard, because in the paper, well, also to you, Rosario, in the paper you mentioned that there are library developers who do not use linters, so they can also introduce vulnerabilities. And I think you also mentioned that during the presentation. Do we have any like empirical data or any gut feeling or statistics? Like how common is this?
You mean for just open source libraries in general, or?
Yeah, so I didn't think of like which libraries, but it's an interesting thing for me that you produce and provide the library, which actually decreases the security itself.
Yeah, so there's the numbers that I've seen. I can try to produce some sources for this and post them in the chat later. But they're basically like so they're published by organizations that do security audits. I've also seen papers on this. So that's where those numbers, the 90-something% of code contains is open source code, and 70% of apps contain vulnerabilities for libraries. That's where those numbers come from. So it is not uncommon, not at all. It's actually very common for open source libraries to contain vulnerabilities. So basically, if you write such a library and publish it, and then it has a vulnerability, then the library's users will be introducing that to their software, and that's a serious problem. This is so the sort of that we are definitely trusting the library developers with not producing vulnerable software, and that trust is misplaced in many cases. Because the library is open source, we can hope that it gets scrutinized, and that's actually how many vulnerabilities get discovered. But the safe thing to do would be for any developer in any team to scan the whole code base, to scan the code that goes into their JavaScript application, the client code, to make sure that the shipping to the client is secure.